No. All right, let's get started with episode number 4. In this video, we are going to learn about deep neural network machine learning with the two neurons. We are going to develop the math, and gradually we will progress in our videos after we understand the math. So let's get started. So I am going to draw two neurons here. So give me some time. That's my first neuron, right? Just make it a little bit small. That's my second neuron. um, just give me 1 second. I was trying to color this, and similarly this as well. All right, I have two neurons right now, and I have two inputs. So let's say now we need to derive the math, right? Don't forget that. So x1, x2. Now we are gonna derive the math a little differently. So let me show you that. All right, so I have the summation unit, I have the activation unit. All right, so I'm forgetting something. If you remember, I'm forgetting the bias, of course. So B1, B2. Now, the way I will do the numbering basically, because gradually I want you guys to learn the Andro and NG way of writing the equations, or the way you write the autoencoders. That's a little bit too far away right now. So let's follow the convention how we're going to write. We can't just, because remember, we were naming this as W1, W2. What if you have 1,000 neuron? Are you gonna name it as W1, W2 up to W1000? No, right? We need some kind of naming conventions so that we don't get confused. So the way I do it is W. Let me write it a little bit on the top of. So I'm gonna say W. Then I'm gonna say output node. Oops. Let me just okay. So I'm gonna say W versus the input. So if you observe here, what is the output node? That is the first node. What is the input? That's 1, W11. Layer is 1 because I'm working on the first layer. I'm gonna call this as delta 1. So this is delta 1, 1 basically. That's nothing but for the first layer. Delta 2, 1 basically for the first layer. Similarly, W output node is 1, input is 2. Similarly, W output node would be basically, just give me 1 second. I want to make sure my math is correct. All right, so we have W. Here we have W. So here would be having is output node would be basically we are working on the second node, and the input is number 1, and we are working on the first layer. Similarly, here it would be 2, and the input is 2, so that's gonna be 2. Now we need to name the biases. I forgot my biases. I forgot to make a bias here, so that's gonna be B, right? Then I need to name the biases as well, so it's gonna be B1 1, B2 1. All right, and I have my outputs as S1, S2 1, basically, which indicates the layer number. A1 1, A2 1. Remember one thing, gradually the level of math would basically so from easy to hard we would be going a little bit slowly, each and every step by step. So here we have A1, we have A2, and of course we need a loss function right here. So I would draw the loss. Now we need to write the equations, the math and stuff like that. So if you observe carefully here, what would be the error equation? Y minus a the whole square. You remember, right? I was explaining you in the videos, right? So but here we have two outputs, not one. So my error would be half, and it will be y minus a1 of 1 the whole square plus y a2 of 2 whole square. So that is nothing but my error. Now I need to define my delta. Remember, whenever I need to compute the gradients, I need to define my delta because it's easier for me to do that. So I am going to define my delta. So if I go with the traditional method, so if I want to write the equations for W1, so I want to compute W1, right? So how am I going to go? So I am going to take this part, if you observe. So del E by del A1 of 1, del A1 of 1 into S1 of 1, S1 of 1 into W11 of 1, right? Now this is nothing but my delta. Remember I said what is delta? Derivative of error with respect to derivative of activation function, all right? So minus y minus a1 of 1 into derivative of the activation function is 1 because we are using a linear. So derivative of x is 1, so 1. Then s1 of 1 with respect to w11 of 1 would be x1. Now you would be asking me, hey, hi, how are you writing that? So in order to avoid confusions, let me make some space maybe here. Let me just write it here. So what would be the equation of s1, guys? Here s1 of 1 would be x1, that is x1 times w11 of 1 plus x2 times w12 of 2 plus 1 times b1 of 1. I know this is getting a little messy right now, but I would show you organized one as well. So right now this is gonna be simply x1. That's what I said. So if you differentiate this with respect to w1 of 1, you get x1, right? So what is my del E by del w11 of 1, or this would be basically delta into x1. What is my delta? This is my delta, right? Now let me go to a new page and explain it to you in a much better way. So I had a neural network with two of them, so I am gonna say, let me just take the picture from here. So if I just take a screenshot, and I just need this photo right here to explain you, because I don't want to draw it again. I'm pretty lazy, you know. So all right, so we do that, and if I just insert a picture here, so if I do it here, so we have the picture now. Thank you very much. All right, now we need to write the math. So what was error? E equals to half y1 minus a1 of 1 the whole square plus half y2 minus a2 of 1 whole square. Now we need to compute the delta, so I want to say delta 1 of 1. I just showed it to you. What was delta? Basically error, derivative of error, I'm sorry, into derivative of activation function. So this is my delta basically. Now I need to compute the gradients, which would, so the gradient would be deltas of that layer, so delta 1 of 1. So I'm computing for this, right? So for this we have this delta, so it will be delta of this into x1, the input. Similarly del E by del w2 would be delta 2 of 1 into x2. So these are the equations I got. Similarly I need to find for the biases as well. So it's gonna be delta 1 of 1, delta 2 of 1. So these are my equations. Then I just need to write my weight matrix, alpha times, you know, w11 of 1, the gradient of that. So this goes here. So it's that easy, though this was the entire math. So now let me show you a clear picture in an organized way if you are looking for an answers. So you can pause the video and write the notations here. Oops, sorry for that. So we develop the math. Now we just need to write the math in the software, that is a Python. These are the equations for biases. These are the weight matrix, final weight matrix. So that's it for this video. In the next video we would be covering 2 layers instead of 1 layer. So we were working on single layer right now, and the next video we would see how to write equation for 2 layers, then again 2 layers with two neurons each. Then we are gonna introduce to the activation functions. Then we are going to introduce two hidden layers instead of one. We'll write the math for that as well, and then we are going to code that math and so on. So I hope you guys enjoyed this video tutorial. If so, do give me a like, subscribe to my channel. If you have any questions, do let me know by doing that in the comment section below. And I hope you guys are enjoying and learning something new in deep learning, machine learning. If so, do let me know by commenting on this video, by liking on the video, or by subscribing to my channel. I'm sorry for that. So let's end the video right here, and I will see you guys in the next video.